For this video, we're going to be discussing solving systems of linear and quadratic equations. So a system is just a set of two or more equations, and the solution to a system of equations is the point where those two equations intersect. And for this video, we're going to be talking about three different types of systems. So first off, we're going to be talking about linear systems. So linear are systems where both equations are linear equations or straight lines. So for example, we have y equals 2x plus 5, that's this red line, and y equals negative 3x minus 4, that's this blue line. They're both linear because they don't have any exponent greater than 1, and they're both straight lines. And their solution is this point right here where the two lines cross. Second type of system we're going to talk about is a linear quadratic system. And a linear quadratic system is a system where one of our equations is a linear equation and the other is a quadratic equation. So in this case, we have y equals negative 1/3 x plus 2, that's this line, and we have y equals 0.25 x squared minus x minus 3, that's this green parabola. And this one has two solutions, the two places where these two functions cross. And then our third type we're going to talk about are quadratic systems. And they're systems where both equations are quadratic equations, like this one where I have y equals x squared plus 3x minus 4, and y equals negative 2x squared minus 6x plus 8. And this one also has two solutions, these two places where our parabolas cross. So we're going to be talking about two different ways to solve a system. We're going to talk about solving by graphing and solving algebraically. So first let's talk about solving by graphing. To solve by graphing, I want to get both equations set to y equal to, or set equal to y, so we want to get y alone on one side. Then we're going to graph both equations using either going by hand or using a graphing calculator, and then we're just going to find the intersection points. So for example 1, I want to find the solution to each one of these systems that is graphed below. So I already went through and graphed these, and we just want to find the solutions. So in this one, there are two solutions. There's one right here at this intersection point, and there's one right here at this intersection point. So the solutions are those 2 points, negative 3, 4, and 1, 0. For this system over here in the middle, there's only one intersection point right here. So that intersection point, which is 3, 0, that is the one solution to this system. And then if I look at this graph, these two functions do not cross at all. They have no intersection point, so this system has no solution. So this is how you would solve by graphing. You just graph them and look for their intersection points. So now we're going to talk about solving algebraically, and specifically we're going to use a method called substitution. So to solve by substitution, what I want to do is I want to get both equations equal to y. Then I want to set the equations equal to each other, and I'm going to use that to solve for x. And then once I know what x is, I'm going to substitute x back into one of my equations to find y. So let's look at how that's going to work. So here's our first example. I've got y minus x equals 2, and y minus 8 equals x squared plus 6. So I want to take these two equations, and I want to get y by itself on both of them. So to do that, here what I need to do is I need to add x on both sides. And over here what I'm going to need to do is I'm going to need to add 8 on both sides. So on this one, I want to add 8 on both sides. So I end up with the equations y equals x plus 2 and y equals x squared plus 6x plus 8. Once I've got my equations both equal to y, since this one's equal to y and this one's equal to y, what I can do now is I can set them equal to each other. All right, they're both equal to y, so I can set them equal to each other. All right, and once they're equal to each other, then I can solve my equation. Okay, this is a quadratic equation, so I want to follow all of my steps for solving a quadratic. So the first step is get one side equal to 0. So I'm going to subtract x on both sides and subtract 2 on both sides so that I get x squared plus 5x, or 0 equals x squared plus 5x plus 6. All right. Now to solve this one, I'm going to use quadratic formula. So I'm just going to go through here and plug in the values from this equation into the quadratic formula. So I know that my a value is 1, my b value is 5, and my c value is 6. So my quadratic equation is -5 plus or minus the square root of 5 squared minus 4 times 1 times 6 all over 2 times 1. So if I work that out, okay, underneath my radical I get 1. So this is -5 plus or minus the square root of 1 over 2. Okay, the square root of 1 is just 1. And so if I go -5 plus 1, that's -6, and -5 plus 1, that's -4, divided by 2 is -2. -5 minus 1 is -6, divided by 2 is -3. So my x values end up being -2 and -3. These are my x values. Now once I know my x values, I've got to find my y values that make this work, because a system always has an answer that has an x and a y. So in order to do that, I'm just going to go back and take one of my two equations, and I'm going to use y equals x plus 2 just because it's easier. And for this equation, I'm going to substitute in my two x values. So I'm going to plug in -2 for x, I'm going to plug in -3 for x. I'm going to work those out to get y equals 0 and y equals -1. And so now I know my two answers. I've got -2 and 0 together, and my other one is -3, -1. So those are the two answers to, or the two solutions to this quadratic linear system. So let's take a look at another example here. So example 3 says solve by substitution, and this time I've got two quadratic equations. You can tell because they both have x squared. So this is a quadratic problem. So first step is, once again, I'm going to get y by itself on both of these. In this one, I'm going to add y to both sides, and I'm going to subtract 20. On this one, I'm going to start by subtracting 20x on both sides. And now I'm going to have 2y equals 2x squared minus 20x plus 50. And for this one, I've got to then divide everything by 2 so that y is by itself. So that my two new equations that I end up with are x squared minus x minus 20 equals y over here, and over here y equals x squared minus 10x plus 25. So now that I've got my two equations both equal to y, I can now set them equal to each other. So I've got x squared, fix that really quick. So now I've got x squared minus 20 equals x squared minus 10x plus 25. So to solve this, I've got to get everything onto one side of the equation because it is a quadratic. So if I do that, I can subtract x squared. I can add 10x. And I can subtract 25. Which leaves me, well, one thing I noticed that happens here is my x squareds cancel out, and I end up with 9x minus 45 equals 0. So instead of this being a quadratic equation, it really just worked out to be a linear equation. So to solve this, I need to add 45 on both sides. So now I've got 9x equals 45. And then to finish this, I divide by 9. That gives me x equals 5. So I'm not quite done at this point. Once I know what x is, now I need to figure out y. So I'm going to take one of my equation, x squared minus 20 minus y. I'm going to plug in 5 for x in this problem. So if I work that out, 5 squared is 25, minus 5 minus 20. If I work that out, 25 minus 5 minus 20 is 0. So my answer ends up being 5, 0. So from these two examples, you can see how to work out a system. You get both sides equal to y. You set them equal to each other. You solve the resulting equation, so you can figure out what x is, and then you plug in x to get your y value. So I'm going to leave you with this try it problem. You need to solve this system by substitution. And this should actually be like this, x squared. All right, so solve this system by substitution.